Thank you everybody for coming. So I'm Brian Simpson-Adkins. I'm a Principal Technical Account Manager here at AWS, and I've got with me my customer and colleague James Fisher, who heads up the AI enablement function for the CTO office at HSBC. And today, as they said, we're going to talk about how you use LLMs to transform operational intelligence. So we're going to take you through now, start off with the challenge that we're starting to see in the industry at the moment. Then we'll talk about how LLMs can help you reduce some of the operational noise that is starting to creep in as the LLM adoption increases. James will talk to you about how they're introducing LLMs into the change management space. And then finally we'll finish with some considerations you might want to be thinking about as you introduce your operational data to LLMs. So when we think about the operational landscape today and you think about your critical applications, for critical applications, most of them have a very hybrid nature to them, right? So there will be an element of potentially load balancers or proxy servers that might sit on-prem that you take a dependency on. There will be potentially the main core application that sits on AWS Web Services itself. Then you might rely on SaaS providers for your APMs, such as Datadog or ServiceNow for your ticketing. And then when you think about the other dependencies around your incident management process, like your paging software, that might sit on a completely different cloud itself, right? So when we're thinking about this kind of federated nature, when we have an incident inside our environment, we have to have lots and lots of specialists to come and triage that problem. And I myself have been on calls where there have been 140 to 170 specialists all triaging this really complex landscape, right? So we want to think about how we can have LLMs play into that space to reduce some of that. Now, if we fast forward next year, according to Gartner, IT spend is going to increase to $6.08 trillion, an increase of 9.8%, which is a significant increase. And whilst I don't have a crystal ball, I can probably assure you a lot of that is underpinning LLM development, right? And then if we think about our platform, so the AWS platform for agentic AI and LLM creation, Amazon Bedrock had an increase in adoption of 400% this year alone, right? So your application teams are really starting to use LLMs within their applications. And these might only be in development at the moment, but they will eventually make their way to production. And then when we think about all the customers that I work with across the GFS sector, all of those customers either this year or next have a focus on developer improvement, right? Productivity improvement. And when you think about that productivity improvement, when ideas become easy to implement and easy to deploy, as we see agents playing into the test space and so on, we start to get to a point where velocity is going to increase. And that increase in velocity is ultimately going to end up with more systems and more metrics heading to the operations departments, okay? So how can LLMs play in that space? So I want you to just think for a minute about critical applications. Think about 3 more critical applications going to production next year. That might come with 90 new metrics, 30 new logs, right? And then them application teams are probably also going to be giving you generative insights as well that you're going to have to deal with, right? So how are you going to parse that information? What happens if that's 30 new systems, right? Think about all the data that's going to start coming your way, right? We want to get more proactive with how we deal with this, because just adding new dashboards and adding new logs is not going to really deal with the problem. So we can do that. So this is more proactive insights. What we want to move to is, rather than that reactive nature that we've got at the moment where a problem starts to happen and then we triage the problem with the 140 specialists, we want to move to a more proactive state where we've got LLMs parsing your logs on a regular basis, looking for patterns inside those logs, and then notifying the right people. Now the key is, you want to notify the right people and not all of the people. So when these LLMs detect a problem, they can raise an incident to your ticketing system with all of the information that you need, and then that person is nice and prepared. And then using RCAs, we can feed those RCAs back into the knowledge bases and RAGs to help these LLMs learn over time. Now we can do that today. So if you look at Amazon Bedrock with Bedrock Agent action groups, we can have action groups reaching out to load balancers to bring back logs, AWS Health to check for service events, the support API to raise tickets against AWS support, and we can bring back data from CloudWatch logs. And we can have all of that information pulled in together and then formulated into a ticketing system such as ServiceNow, where we raise a ticket against, say it was the F5 that was going wrong, we could raise a ticket to the F5 load balancer team, have them have all of the log information, and then they can triage the problem. And then if we start building RCAs in a way that models can understand them, so we identify the positions in the logs, the patterns that were there, the pieces of data we saw, we can pass that back into RAGs, and eventually we will get to a position where these LLMs start to understand the patterns of our systems going wrong. Okay? So now I'm going to hand over to James. He's going to take you through how HSBC is introducing LLMs into the change management process.
Thanks, Brian. Thank you. The probabilistic nature of LLMs presented initial adoption challenges within key strategic processes within the highly regulated industries such as financial services. To allow the safe, early adoption of technology to develop the necessary skills, identifying complementary or sample-based processes provided a low-risk scope where the impact of a false positive or false negative model outcome was minimized. Operational resilience is a primary technology objective with a firm dependency upon the quality of service management processes. These processes can be data heavy, they have many manual steps, and complementary manual problem and incident reviews are conducted at HSBC manually across approximately 12% of standard changes. To scale the existing complementary manual reviews across all changes would require a significant uplift in resources. To allow the scale and improve quality, HSBC explored options for automated and safe evaluation of change, problem and incident records using large language models. This led us to come up with a solution called the Service Management Quality Assurance Application, or SMQA. SMQA is a hosted application that uses generative AI to perform high capacity, full scope, automated quality assurance of ServiceNow change requests, incident records, problem tasks to reduce manual effort and identify anomalies for exception, treatment and remediation. SMQA takes the data from existing trusted source ServiceNow and with the back-end LMM integrated to review information based upon a framework designed by our service management SME team. HSBC adopted a DevOps model a number of years ago, and what we see is smaller changes at a higher frequency with reduced risk, but that approach obviously can increase the burden on any additional manual processes. By bringing generative AI to the solution and feeding thousands of records, RCAs, problem records into Amazon Bedrock, we built a framework that passed the change that was raised into Bedrock, had it analyze the change text, the testing output, the implementation plan, the recovery plan, the technical components, the number of services this change will interact with, and then flag where needed the change for a manual review. Also, this has an added benefit that it's integrated via an API into the ServiceNow platform so the teams can put in place into the pipeline. When it gets approved, it is automated. We're exploring more features for this solution going forwards, and we're going to try and improve the quality further and also bring the reviews further to the left in the overall process. The parallel run in production showed that the tool was typically more effective at identifying anomalies than a human. And whilst it's still early days, what we've seen is that we can now scale the number of reviews to 100% of all normal change reviews, and also we've seen an early stages of a drop in disruptive changes being recorded. So in all, it's built confidence in the technology to take this solution forward. Thanks, Brian.
Awesome, thank you, James. So as you just heard from James there, using the past to predict the future is an important point, right? But you can use other operational data for this. So what this is showing up on screen here is, and there's a code sample in the right-hand corner if you want to take a picture, but this is using AWS cases from your organization, which there could be thousands of these cases that you're creating per year, right? We can use LLMs to parse that data and then create aggregate groupings that we can learn from later. So what you can see over on the left-hand side is us talking to an MCP server that is we're asking a question of, can you give us a summary for the last 3 months? And we can probe that data to see what struggles we're actually having at the moment. And then over on the right-hand side, we can ask Kiro to produce proactive controls that we can run inside the pipeline, which might be a Groovy script that helps us eliminate this problem from ever happening again within our organization. But proactive on its own is not necessarily enough. So over on the left-hand side, we have all of the proactive controls, which is these 24-hour operations that go out and use agents to scrape logs and look for patterns. We have the agents and the models that are parsing your cases or your trusted advisor data. But over on the right-hand side, you've woken a person up out of bed at some point, right? And that person is going to need the same tools to traverse that environment. You don't want that 140 specialists, you want a couple of people that can traverse your entire stack. And we can do that using something like Kiro CLI with MCP tools. And here's an example of that. So what we've got here is MCP servers running in Kiro CLI, and we're asking here, what's the current P99 latency metric for the payment system, because we're seeing some latency inside the client app at the moment. And that client app has got metrics inside Datadog, and we're pulling them metrics back, and then we're presenting them on screen. And what you can see is it's saying the P99 latency metric is 2,000 milliseconds, which is above our threshold. Now what's important here is, inside the MCP server, in the response that we gave back our thresholds, because models are all about giving context. So the more context that you can feed back to that model, the more accurate it can talk to you and give you feedback on it. So if we say that our threshold is 1,500 milliseconds, in the response it passes that back, and then it makes a decision that these are above, and then we can move on to the next process. So some considerations that you want to be making. So I see the kind of the AI operations puzzle as 3 stages at the moment. So we've got kind of the top layer, the model access layer, which is where your Bedrock, your Kiro CLI and that play. Then we've got the middle layer, which is the, as I call it, the unified access layer. And that is where your agents and your MCP servers live. And then we've actually got your resources. Now, you want to be paying attention to the bit that's in the red, right? If you're not, at the moment, if you've not got a strategy around how you manage agents and MCP servers, you should be thinking about that. Like, there is no right answer on this, but there might be an answer for your organization. You need to think about whether you're going to self-build agents. Are you going to take agent that are built by vendors? Are you going to allow multiple application teams to build the same MCP to talk to the same resource at the bottom? Or are you going to centrally host them? So you want to be putting a strategy in place now so that you can put architectural principles around them that will guide your application teams. You also need to be thinking about data sensitivity. So whilst most organizations have put some level of classification around their organizational data, like you may even classify emails when you send them out, most operational logs were never intended to be open to a model. Right? So an F5 log, as an example, was only meant to be open to an F5 administrator. So why did it matter if it had sensitive data in it? Now it matters, right? You're going to expose this to an LLM, and this LLM could expose that to something downstream. Now you can use Amazon Bedrock guardrails to obfuscate some of this data. So I would encourage you to go and have a read about how Bedrock guardrails can help control your data flows. The next bit is model and agent access. So this kind of breaks into 3 areas, which is how does the model get to the data that you're trying to get to? So that'll be the security groups, the firewalls, the access permissions, right? You need to think about how you manage all of those aspects so that models can traverse the environment nice and safely. Then you've got the middle layer, which is when the model gets there, what can it access? Do you want that model to bring back the entire log, right? If you're bringing back logs from an F5, there might be shared data in it. Those F5s are probably shared between other applications. Do you want all administrators to be able to see all logs? You need to take that concern, right, or that consideration. You need to think about what your access tokens are actually giving people access to. Then finally, we've got the who can run these agents. So, you need to start thinking about like those agents. Do you want a junior administrator to be able to bring back all the logs, or do you want to ring fence their tokens so that they can only access certain parts of the system? So these are things that you need to be thinking about. Then we've got monitoring and observability of your agents. You need to understand the performance of your models and the LLMs and the prompts that you're actually running. So when we think about performance, tokens aren't free. Tokens cost money. So you need to be aware of how much your output is actually costing you. Is your output too verbose? Could you do with a smaller output and get a meaningful, still a meaningful summary? Like the case solution that I showed you before. I worked that out to about 200 characters. If I keep it to 200 characters, I get a pretty good summary. If I go below that, I start losing detail, right? So you've got to think about them considerations. You're also going to upgrade your models at some point. So you're going to go from a version 4 to a version 4.5. And when you do that, you need to know whether your response time is still the same. So by monitoring these outputs, you'll get an understanding of your environment over time. And then lastly, the most important bit of all is traceability. So Amazon Bedrock does have traceability built into it. You need to enable it. You need to write that out to logs. But you are going to need to know at some point, what did the model get asked for? What data did the model give out? And who did it give that to? Because eventually you will have these agents taking actions on your behalf, right? And if you get into a scenario where there is a data breach because of something that has been given out and you need forensics analysis around that, you need to think about how am I going to ring fence this data so I can ensure integrity of this environment, right? Because otherwise it won't hold up in a court of law. So all of those processes that you put around EC2 instances where you took snapshots and you copied them off and you put permission boundaries around it, you have to start thinking about the same thing for your agents and your LLMs. So just to kind of wrap up, we want to move from this kind of manual triage where we've got siloed environments where logs and monitoring are kind of siloed to key individuals, where resolution kind of takes hours because we've got multiple people trying to triage their part of the puzzle, to this more proactive detection where LLMs are able to parse our entire environment with metrics and logs to identify where the problem is and then wake the right people out of bed, not all of the people. And what that'll do is it'll free up your engineers to make more decisions and not just be hunting for data, because you want to use your expensive resources in the right place. And then you've got to remember that for every incident, start to write it as though you were writing for an LLM. Because in the future, it will be those LLMs that are parsing this data, and you want them to learn from your problems so that they start to pick up on these patterns much earlier in the process. Okay, so if you have any questions, we have a booth for enterprise support at C50. I'd encourage you to go and speak to some of them specialists that are on the booth. And with that, thank you for listening. Please fill out the survey because it helps us improve this session, and I hope that was useful for you.